Section 3 was standard form. Section 3 was slope-intercept form. Section 4 was point slope form, and now in section 5 we have this new one called standard form. Yeah, lots of different ways you can write the same equation, and you need to know all three. Actually, this is the last one we're going to learn about here, standard form. Standard form has a purpose, but it's not as useful to us as slope-intercept form is. So most of the time when you're graphing or when you're talking about an equation, you're going to probably want to put it in slope-intercept form, because then you know more about the equation than just standard form or point slope form. But standard form does have some uses, which we'll get into later on in this class, a couple chapters from now, maybe next chapter, I can't remember. All right, this is standard form right here. Capital AX plus capital BY equals capital C. In standard form, what are these two letters right here, X and Y? What are those? No. They are variables, that's it. So let me get rid of this circle. You got X and you got Y, those are your variables. What are A, B, and C? They're just random letters? They're not letters at all. They're just numbers. So when you're given an equation in standard form, you will see the X and the Y. You will not see A, B, and C. A is attached to the X. It's the number attached to X. B is the number attached to Y. And C is the constant that's on the other side of the equal sign. This is just some number sitting here. There's no variable attached to it at all. That's what standard form looks like. Notice that the X term comes first on the left side. The Y term comes second on the left side. Then we have the equal sign, and then the constant term is all by itself on the right side. Now we could put standard form into slope-intercept form by solving this equation for Y. And we're going to be doing that in this section somewhat. So you need to know how to do that. Every single linear equation can be written in standard form. All of them can. Just like any equation can be written in slope-intercept form or point slope form. You will have to do problems that require you to write an equation in standard form. So they might ask you to come up with the equation and then put it in standard form. And you'll be able to do that by the end of this section. To get an equation in standard form, first, get the X term in the first position on the left. Then, the Y term in the second position on the left. Then the equal sign, and then the constant C on the right side of the equal sign. Once you have all of those in the correct position, then you're most of the way to being in standard form. There are some rules that we're going to have to learn that we have to follow for standard form. Somebody a long time ago made up those rules, and we have to follow it to be actually in standard form. There's 3 rules that we're going to learn. But the point is, right now, X comes first, then Y, then the constant on the other side of the equal sign. Okay, once you have those terms in the correct positions, then you have these 3 rules that you have to follow. There's a rule for A, there's a rule for A and B, and then there's a rule for A, B, and C. And I'm talking about the numbers that are involved in this standard form equation. The rule for A has to be positive. In other words, A has to be greater than or equal to 0. The rule for B, so for A and B, this one's kind of a weird one. A and B can't both be 0 at the same time. A can be 0 on its own. B can be 0 on its own. But A and B can't both be 0 at the same time. If that happens, then your equation AX plus BY equals C. If A is 0, then this term disappears. If B is 0, then this term also disappears, and I'm left with 0 equals some number. Is that true? No, it's not true, okay? So this one usually takes care of itself. If you're looking at an equation, this rule is almost always already satisfied, so we don't have to worry about it too much. The third rule for A and B and C is no fractions, no decimals. So they have to all be integers. Technically, there's another part to that with a GCF of 1, but we don't know what that is yet, I don't think. Do we? Do we know what a GCF is?
Greatest common factor.
Greatest common factor. Do we know how to factor yet? We do? Have we factored out greatest common factors from 3 terms? I don't think we have. So we're going to leave off that last part. The part you need to know is that A, B, and C have to all be integers, period. You can't have fractions. You can't have decimals. If you have fractions and decimals, you got to get rid of them. So that should be the rule that you guys all like, because you don't like working with fractions. I know this. Nobody really does. So this is the rule that makes life nice for standard form. You got to get rid of the fractions. Put them in the right order, then get rid of the fractions and decimals, and then you're done. So we have 6 examples here. Write each equation in standard form. Identify A, B, and C. So the first thing I want to do is get all the terms in the correct order. Then try to follow the 3 rules. Okay? So for this first one, do I have my terms in the right order? No. What's in the wrong spot? So the y is supposed to be on the left side. Is it on the left side? Yes. The 4 is supposed to be on the right side. Is the 4 on the right side? Yes. The x is supposed to be where? On the left. So that's the term that's in the wrong spot. I want to move this guy over here. How do I do that? Add 3x to both sides. When I do that, then I have the 3x, which I know needs to be on the left, then a positive y, so we're at plus y, equals 4. Now is this at least all the terms in the right order? Yes. So once the terms are in the right order, the x term first, the y term second, the equal sign, and then the constant term, then you try to follow the rules. Rule number 1 for A, is A positive? Yes. So that one's followed. Are A and B both not 0? Yes. We have an equation sitting in front of us. A is actually what? The number on x is 3. And finally, A, B, and C have to all be integers. Are we looking at integers, or do we see fractions or decimals somewhere? They're all integers. So are all 3 rules being followed? Yes. And because all the terms are in the right order, this is now standard form. So we can put a box around that. And then we have to identify A, B, and C. So A equals, B equals, C equals. What is A? It's 3. The number on x is A. What's B? 1. The number on y is B. And what's C? 4. Because that's the constant term on the right-hand side of the equation. So that's what you have to do on these problems. Let's take a look at the second one. X equals y minus 5. Is that in standard form? Why not? The y is on the wrong side. Okay? We do see x, y, and then the constant term, but the y is on the wrong side of the equal sign, so that has to move. What do? That's a positive y. To get it to move, I got to subtract y from both sides. What do I get? Write them in the right order. X minus y equals negative 5. Okay, so are all of the terms in the correct position now? Yes. All right, so try to follow the rules. The first rule is what? Is A positive? Yes. We don't see a negative sign on the x term, so A is positive. The second rule. They can't both be 0. Are both A and B 0? No, we don't have a false equation here, so we're good there. How about the third rule? Do we see any fractions or decimals here? No. So are they all integers? Yes. So is this standard form? Yes. So we follow the three rules. All the terms are in the right order. Therefore, this is standard form. And we need to identify A, B, and C. What is A? 1. What is B? -1. And C is good. All right. See if you can do the third one, but only the third one. Don't go on. So what do we do? No, we can still put it in standard form. Even though there is no x value, it can still be written in standard form. So notice what we have. We got this -4y here, and then a -6. There's no x on that. And then a 2 over here. So what do I need to do? Yeah, we got to add 6. The constant has to only be on the right. So I have to add 6. And that gives me -4y equals 8. Is that standard form? Close. Since there's no x term, x is 0. Well, not x, a is 0. A equals 0. Okay, now are we following the rules? Up here on this rule it says A has to be positive. But what that really means is you can't start with a negative sign. Are we starting with a negative sign? Do you see a negative sign here? Yes. So technically, we need to get rid of that negative sign. Which means to do that, I need to multiply both sides of the equation by -1. Which just changes all the signs. Yeah, it gives me a 4y equals -8. So for that first rule, just look at that first number. Do you see a negative sign to start? If you do, change all the signs. And that will take care of it. So A is 0 here. What's B? 4. What's C? -8. And you're done. By the way, I could actually just solve this equation for y right now. I could divide the whole thing by 4. Okay? And in that case then y would be 1 and B would be 1 and C would be -2. So let's take a look at this one on the bottom. What do we need to do first? So there's a y here and a y over here. I don't need a y on the right. I need all my y on the left. So that means I need to do what? Subtract 10y from both sides. Which gives me -17y equals 0. All right, see if the rules are being followed. Are we starting with a negative sign? No. Are A and B both 0? No, so we're good there too. Do we see any fractions or decimals? No. So is this standard form? Yes. And we need to say what A is, what's B, and what's C. A is 12, B is -17, and C is 0. So that's the idea with standard form. We haven't seen any fractions yet. Obviously, the last two problems that we're going to be working on have fractions on them, so we need to figure out how to get rid of those fractions. Fractions have to disappear completely. In order to get rid of the fractions completely, you are not going to multiply by the reciprocal. You're going to multiply by the common denominator that you see. So in this case, because we only have one denominator, we're going to multiply this entire equation by 4. As soon as I do that, the fractions from every single term will completely disappear. 4 times 3/4 y gives me just 3y. The 4's here disappear, and I'm left with 3y. Equals what? 8. Okay, are all the terms in the right position? Yes. So is this standard form? We're not starting with a negative sign. A and B, A is 0, but B is not. And then finally, we got rid of all the fractions, so we have all integers sitting here. So yeah, we're in standard form right now. This is the answer. A equals 0, B equals 3, and C equals... You can't have A, B, or C be a fraction or a decimal. If it is, it's wrong. So you need to adjust your equation. For this last one, all kinds of stuff is wrong here. What do we need to do first? Multiply by a common denominator. So you could put all the terms in the right position. We have terms that are in the wrong spot right now. You could get rid of the fractions immediately, because we have fractions sitting here, so we have to multiply by what? 3. It's your choice. One or the other first. Let's get rid of the fractions right now. To do that, I have to multiply both sides by that common denominator of 3. Every single term gets multiplied by 3. So for this term on the left side, what do I get? 2x equals what? 12y minus 1. We had to distribute the 3 to both terms inside. Don't forget that. Every term gets that 3. Now I got rid of all my fractions. What's next? The 12y is in the wrong side, so I got to move it to the left, which means I need to subtract 12y from both sides, which gives me equals -1. Okay, check the rules. Are we starting with a negative sign? No. Are A and B both 0 at the same time? No. Do we have any fractions or decimals? No. So are we following all the rules? Yes. Are the terms in the correct position? Yes. So this is standard form. And we need to also say what A is, B, and C. A equals 2, B equals -12, and C equals -1. There you go. Okay. That's how you do standard form. It does take that much to get standard form written down. So make sure you remember the 3 rules on top of where to put each one of the numbers. Typically your standard form question is going to be worth 2 or 3 points on your quizzes and tests. Putting the terms in the right position is only worth 1 out of those 2 or 3 points. The rest of it comes from following the rules that are here. The second topic that happens immediately after you understand standard form, so really they were just introducing standard form, and now we're going to get into how we can use standard form. This is really the only purpose behind standard form for you guys in Algebra 1, for now, until we learn about solving systems of equations, is graphing using intercepts. We already know what the y-intercept is. What's the y-intercept? Where the graph crosses the y-axis, that's right. There is such a thing, though, as the x-intercept also. What would that be? Where the graph crosses the x-axis, yeah. So an intercept is just where the graph crosses an axis. It could be either the x or the y-axis. So therefore, the x-intercept is where the graph crosses the x-axis. And the y-intercept is the same definition, where the graph crosses the y-axis this time. So now that we know that vocabulary, we can kind of talk about the x and the y-intercepts on a graph. So for this first graph, we want to find out what the x-intercept is and what the y-intercept is. When the graph crosses the y-axis, what is the x-coordinate? When the graph crosses the y-axis, what is the x-coordinate? Anywhere along the y-axis, what is the x-coordinate? I'm not looking at this particular problem. I'm just saying when the graph crosses the y-axis, what is the x-coordinate? It's 0. Everywhere along the y-axis. So my x-intercept is going to be 0, comma, wherever the graph crosses. So my y-intercept is 0, comma, wherever the graph crosses. Where does this graph cross? 40. So my y-intercept is 0, 40. My x-intercept is where the graph crosses the x-axis. So along the x-axis, what is the y-coordinate anywhere on the x-axis? It's 0. So it's going to be something, 0 for my x-intercept. Well, where does the graph cross? Seems to be about 20. So 20, 0 is my x-intercept. Because the y-coordinate there must be 0. So it's 20, 0. See if you can come up with the x-intercept and the y-intercept for the second one now on your own. All right, so what is the x-intercept? -2, 0. The x-coordinate is -2. The y-coordinate is 0 for this ordered pair right here. And the y-intercept would be 0, 3. The ordered pair right there, the y-coordinate is 3, but the x-coordinate was 0, so 0, 3. Notice that all you need to graph a line is 2 points. And what do I have here and here? 2 points. So if I know the intercepts to an equation, I can graph the equation quickly. Graphing using intercepts is a viable technique for graphing. You don't have to do rise over run all the time, okay? So we're going to learn how to graph using intercepts right now. All you need to graph a line is 2 points. If you know the x and the y intercepts, then you can graph the line every single time. So find the intercepts of the equation and then graph. To do that, I want you guys to do this. What is the y-coordinate at the x-intercept? The y-coordinate at the x-intercept is 0. So if I want to find the x-intercept in this equation, I need to plug in 0 for y. What is the x-coordinate at the y-intercept for this equation? 0. So if I want to find the y-intercept of this equation, I need to plug in 0 for x. When you're graphing using intercepts, you're going to set up a table like this. It's a very simple table. You'll put in a 0 for y, and you'll put in a 0 for x. That's going to give you the 2 ordered pairs that you need to graph the line, the 2 intercepts to the equation. So now all I need to do is plug in 0 for y, and that will give me my x-intercept. If I plug in 0 for y in this equation, what happens? 4 times 0 is 0. This term disappears. It's almost like it's gone, right? It never was there in the first place. So what I'm going to suggest you do is, instead of doing what I did, which is scribbling it out, cover it up with your finger, or just pretend it's not there somehow. If you cover that up with your finger, now it's gone, and I'm left with what equation? 2x equals 12. So to solve now, all I got to do is divide both sides by 2, and I get x equals 6. So when y is 0, x is 6. That's my x-intercept. And now I can graph 6, 0 on my coordinate plane. It's right there. That's my x-intercept. Now I can do the exact same thing for the y-intercept. I plug in 0 for x this time. So if I plug in 0 for x, it's like 2 times 0, which is 0. That term disappears. And I'm left with 4y equals 12. Well, if that's the case, then what must y be equal to? 3. So by doing that, I can get this ordered pair, 0, 3, very quickly. And then 0, 3 is right here on my graph. Do I know what the slope is from my equation? No. But I do know what my intercepts are, and that's 2 points, which is all I need to draw a line. So now I can draw on my line, going through my intercepts. The line still needs to go all the way through the grid that I'm given, and I still need to put arrows at both ends, but that is the graph right there. So let's take a look at the second equation. I want to do exactly the same thing. I want to graph using intercepts. So what do? I draw my table. It's still an XY table, but a 0 for y and a 0 for x. That gives me my x-intercept and my y-intercept. I'm covering up the y because I'm plugging in 0 for y. So now that term disappears and I'm left with 3x equals 3, which means that x must be 1. Okay, I do the same thing for x now. So what happens? 0 goes in here, which basically turns this term into 0. It's gone, and I'm left with, so y equals 3. There's already nothing to do. We already know y equals 3. So I put in 3 right there. Now what do? So graph it. I got 1, 0, which is here. And I got 0, 3, which is here. That's all I need. I can draw on my line now. So that's the graph. Notice once I have my graph, I can probably come up with slope-intercept form kind of easily. From here to here, I have a down 3, right 1 situation, so my slope here is negative 3, and my y-intercept is 3, so my slope-intercept form would be y equals negative 3x plus 3. It's kind of easy to come up with slope-intercept form once you graph using intercepts, but graphing using intercepts is kind of nice. So, we have 2 more. Both of these kind of are in standard form, and we want to graph them. What should I do on this one? Make your table. So my table will be x and y, 0 and 0. Plug in 0 for y. What am I left with? Okay, negative x equals 3, which means that x must be negative 3. If you can't do it in your head, then write it down. Negative x equals positive 3. I want positive x, which means I need to multiply both sides by negative 1, which gives me positive x equals negative 3. If negative x is positive 3, then positive x must be negative 3. And if I plug in 0 for x, 2y equals 3, which means that y must be, if I solve for x, if you can't do it in your head, write it down. 2y equals 3. Divide both sides by 2, and you get y equals 3 halves. So 0, 3 halves is my y-intercept. Not that big a deal. We can still graph that. We have negative 3, 0, which is there. And then we have 0, 3 halves. So 0, and then 3 halves is like 1.5. So I just go up to 1.5 and I put my dot there. Or I can count by halves. I can go 1 half, 2 halves, 3 halves. Once I get both of those dots on there, I'm good. Just draw on the line. And you're done. It's nice to show your work. On these problems, I have to see the table. I want to see the dots. I want to see the line drawn all the way through the grid. If you need to do extra work like we did here and here, that's fine. Write it down. I want to see it. Now this last one, what form are we actually in? We're already in slope-intercept form. So technically I could graph it right now in slope-intercept form. But the directions say plot using intercepts, graph it using intercepts. So I still need to do the xy table. I still need to plug in a 0 for y and a 0 for x. It just might take an extra step to get these numbers. Well, for the y-intercept, that's when x is 0. What is the y-intercept here? It's 5. If I plug in 0 for x, this term disappears and I'm left with y equals 5. We already knew the y-intercept was 5. That one was easy. For the x-intercept, though, I got to plug in 0 for y. So if I plug in 0 for y, then I'm left with 0 equals negative x plus 5. I could subtract 5, or more easily in this case, add x to both sides. And now I get x equals 5. So I have 5, 0, which is there, and 0, 5, which is there, and that's enough to draw my line. So I'll draw that one in. There we go. And now since we have like another minute or so, let's take a look at slope-intercept form for that equation since it's already in slope-intercept form. If I'm going to graph using slope-intercept form, what do I do? Start at the y-intercept, which is 5. So I put a dot there, and then I use the slope, which is -1, and I want to put that over 1 so that I see the rise and the run. So -1 means from here I go down 1 and then right 1. Down 1, right 1, down 1, right 1, down 1, right 1, down. Look at that. With slope-intercept form, using the slope and the y-intercept, I get exactly the same line. And I should. You're only going to get one graph for an equation, no matter what form it's in. So it's kind of a nice thing to see on that last one. You're capable of doing 8 through 22 on your homework. It is all, not odd, 8 through 22. So make sure you do all of them. And I believe there's graphing, so you're going to want graph paper.